We put them in what's called a biconditional. Now, notice the word true. The converse has to be true. If the converse isn't true, then you cannot combine them into a biconditional statement. We write a biconditional by joining the two parts, the hypothesis and the conclusion, with the phrase if and only if. So we get rid of if and then, and we use if and only if. I didn't put them on Classroom today.
Didn't you put all the notes for this week?
I put the assignments for this week on the Classroom, but I didn't get a chance to do these because I didn't know I didn't have them. So we take the if and then out, put them together as an if and only if. It's a biconditional. Take a look at our first problem. If two angles have equal measure, then the angles are congruent. First of all, decisions. Who was here yesterday? Courtney, what's the converse of this statement?
If the angles are congruent, then they have equal measure.
Correct. If the angles are congruent, then they have equal measure. That would be our converse. If the angles are congruent. Does everybody know what this symbol means?
Congruent.
Congruent. Then they have equal measure. Morgan, is that true or false?
That's true.
That's true. So since the converse is true and the conditional is true, we can combine them together as an if and only if, our hypothesis and our conclusion. So our answer would become this. Ooh. Two angles have equal measure if and only if they are congruent. Since the statement and the the converse are true, we combine the hypothesis and the conclusion with if and only if. Two angles have equal measure if and only if they are congruent. questions so far? Ms. Hickey? Two angles have equal measure. If and only if they are congruent. Be our final answer. Doesn't he have a pass for coming back later? And let's talk about definitions in geometry. Because we can also write a biconditional, actually, before we talk about definitions, we can write a biconditional as two conditionals that are converses. So I want you to be able to do two things. I want you to be able to combine as a biconditional, write as an if and only if, and I want you to break an if and only if back out. Two numbers are reciprocals. If and only if their product is 1. I would like you to write this as a conditional statement and its converse. And I think they got the conditional statement. I'll help you out. I'll get you started. If. Guys, what comes before the if and only if in this statement?
Reciprocal.
Yeah. If two numbers are reciprocals, then
Their product is 1.
correct, Mr. Conway. So that's the conditional. If and only if, two parts. The part that comes before if and only if becomes the hypothesis. The part that's after if and only if becomes the conclusion. Then the second conditional statement you write is the converse of this one. And the converse of this would be what? Canaan Baxter. I'll start you out. What comes after then, Canaan?
There's
Keep going. Make that come after if.
their product is number 1. If their product is 1,
Then,
then two numbers are reciprocal.
sounds like you know what you're doing.
What's that first one?
Which part's that?
If two numbers are reciprocals, then their product is 1.
That's the conditional statement. And then the second one is the converse of that. So we want you to be able to do two things. Put two together as a biconditional and take the biconditionals back apart.
So,
All right. Finally, definitions. In order to write a good geometric definition, you got to have the following. It's good if it can be written as a biconditional. So that means both. It has to be true and its converse has to be true. Right as if and only if. A good definition uses clearly understood terms. something we commonly understand or already have been defined. So we use clearly understood terms. We don't bring in new stuff into a definition. It's precise. We avoid large, sort of, and almost, words like that. You know, it's about this. No, it's exactly something if it's a good definition. It's precise. And it's reversible. You can write a good definition as a true biconditional.